うんうんうん Okay, let us start. Very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session on the course Farm Machinery. This course is taught by Professor V.K. Tiwari, Director IIT Kharagpur. And what he'll be doing in this particular session, that I'll be posting some of the objective type questions based on the previous week's content in front of you all, and what you have to do, you have to just answer them uh, using your knowledge, and at the end I'll tell you the correct option as well as we'll discuss. Okay, so the very first question for the day is this one. For the droplet size data given below, what is the mean droplet diameter? D32. Okay, mean droplet diameter is also known as D32. Okay, it's an important parameter to uh, judge the droplet size which is coming out of a sprayer. Okay, what is how our nozzle is functioning and whether the droplet size as well as the spray pattern is up to the standard which we want. Okay, so that is an important parameter. Here you have been given two columns. First one is mean diameter, and the diameter is in micrometers mu. Okay, and another thing is uh, number of droplets in each class size range. Okay, so you have to just use the formula D32 equal to sigma ni di cube over sigma ni di square. Okay, di would be the diameter. Okay, that has been given in the first column. Ni would be the your number of droplets that has been given in the second column. So please take your time. I'll give you 5 minutes, 5 good minutes. Please try to calculate the numerator and denominator, then try to divide. Try to calculate them separately, then try to divide and tell me what is coming. Okay, then we will discuss what are the other mean diameters also as well as their significance. Okay, yes. Please do try to solve.
Sir, can you describe the question once more?
Yes, yes.
I was not able
I'll
to hear.
describe it once more. In this particular problem, we have been asked to calculate the mean droplet diameter, that is D32. Okay. So D32 is given by the formula sigma ni di cube over sigma ni di square. Ni is your number of droplets. Okay. Di is your mean diameter. So how you will calculate this? For the numerator part of this formula, you have to do ni into di cube. So how it will go? First term would be 286 into 85 cube plus 305 into 112 cube plus 258 into 138 cube. Okay. Similarly, for other terms, you have to calculate the numerator first. On following the similar note, there would be a denominator that would be ni di square. Okay. How you will do that? 286 into 85 square plus 305 into 112 square, then 258 into 138 square. Okay, then sum all the terms in similar pattern. You will calculate numerator separately, then denominator separately, then the 32 would be the uh, fraction numerator upon denominator. Okay, then you will get a value, then you can calculate. Okay, yes.
Okay, sir.
Okay, please do try to calculate.
Sir, B 166.
Okay, okay. Very good. Very good. It is indeed a lengthy question. That is why I gave you enough time. Okay, it is 100% correct. Very nice. You have solved it very correctly. It is 166 micron only. Okay. See here, the entire procedure has been given here. Ni di cube over ni di square. This was the formula. Okay. So here mean diameter has been given. Then the in the second column n has been given. Then all the parameters tabular form also you can calculate in the examination so that you don't commit any mistake. Okay, if it is an objective type then directly you can use the calculator also, but it would be becoming out of memory. Okay, that is why sincere advice, follow a tabular form and jump into this question when you have enough time. Okay, it is not like that at the very first attempt you are attempting a very lengthy question. Okay, so see here, everything has been calculated. Ni di square, ni di cube. Okay, and you would get this value, and by division you would get 166.67 something, and that would be approximately equal to 166 micron. Okay. Moving forward, these are the different mean droplet diameters. First one was D32, which we calculated in this particular question. It is also known as Sauter mean diameter. Okay, it is defined as the diameter of the sphere that has the volume to surface ratio as the entire distribution of the droplets. Okay, so that is the exact definition of Sauter mean diameter. Okay, formula is this one. You already used NIDI cube over NIDI square, that whole in sigma, and numerator represents what the numerator term is. It represents the total volume, and denominator represents the total surface area. That has to be same. That is the meaning here. Okay. Moving forward, another diameters which are important for spray droplet characterization. Okay. First one is arithmetic mean diameter, that is also known as D10. Okay, the formula is sigma ni di over sigma ni. Okay, ni is similarly the number of droplets, di is the diameter of droplets. Okay, then D20, D10 was your arithmetic mean diameter, D20 is your surface mean diameter. Okay, D20 is sigma ni di square over sigma ni di. Okay, D20 surface mean diameter. Then D30 was your volume mean diameter that you already calculated, sigma ni di cube over sigma ni di. Okay, this is the thing here. Then quadratic mean diameter D40. Okay, that is in similarly the exponent is increasing the first place. Okay, D40 means take 4 from here. For remembering the formula, I am telling you the short trick. That would be sigma ni di to the power 4 over sigma ni di cube, one exponent less in the denominator. Okay. Then mass mean diameter, again sigma ni di power 4 over sigma ni di square. Two exponents they have reduced. Then volume surface mean diameter, that is sigma ni di cube over sigma ni di square. Same thing. No changes here. Already known as D32. Okay, or volume surface mean diameter or Sauter mean diameter. Then harmonic mean diameter, this is the last one. This is sigma ni over di. Okay, if it comes in your examination, then please do calculate it in the similar fashion which you have calculated D32. Okay, moving forward, today a lot of numericals are there, so please and keep your calculator handy. Okay, it will be useful. Yes, this question. A boom sprayer is operating in rows at a speed of 6 kilometers per hour and it covers a 30-hectare cereal crop farm. It, if only 85% of the time is utilized in actual task in an 8-hour day, then the boom length of the sprayer is equal to. Okay. So see here, actual field capacity, theoretical field capacity, these concepts which you have to use. Field efficiency is actual field capacity upon theoretical field capacity. Theoretical field capacity is S into W divided by 10 hectare per hour. Okay, actual field capacity you can calculate here. Okay, 30 hectare is being covered in 8 hours. That would be AFC. AFC would be equal to 30 by 8. I'll just write down if the things are becoming more complicated. See here, field efficiency is actual field capacity divided by theoretical field capacity. Actual field capacity would be equal to 30 divided by 8 hectare per hour. Okay. And theoretical field capacity is S into W. This is 6 into 8. 6 into, let us say that W is W. The width or boom length is equal to W. Then you have to divide it by 10. Okay. And this field efficiency has been given. This has been given as 85. Try to calculate the W. Keep it here 0.85. Okay. This would be the approach. Okay. Easy question, straightforward question. Okay. Just try to solve it. In examination also, these type of questions are very common, straightforward questions. Okay. If it comes in the examination, please solve it. Okay. Yeah.
Option B, 7.75.
Yes, yes, yes. Very good. Very good. Straightforward question. It is 7.35 meters only. Okay. See here, the important point to note is actual field capacity and theoretical field capacity, both I have taken in same unit, hectare per hour. So in the examination, please bear in mind that you have to use the same units. Okay. Yes. Similarly, this is the okay detailed solution. Okay. If you have any doubt at any point of time, then you can please see it. I have already told how the things go in this particular question. AFC is 30 over 8. Okay. AFC you have calculated, then TFC is S into W divided by 10. Then it is will not be 80% here, it would be 85 at this place. It would be 85 percentage. Okay, that is equal to uh, that will give you the width directly 7.35 meters. Okay, moving forward, another numerical. A round bottom sprayer tank has the capacity of 1000 liters, depth of 0.85 meters, diameter of 1 meter, and it is provided with a mechanical agitation. And the agitation factor has been given as 0.89. Four pedals are there, which are 220 millimeters long, 180 millimeters wide. They are mounted on the agitator shaft, and the shaft center line is positioned as at 225 millimeter above the bottom of the tank. What would be the minimum revolution per minute for agitating a mixture having 15% oil and 85% water? Okay. The last two things have got no role in this particular question. The mixture can be anything, but you have to apply the empirical formula and you have to calculate what is the minimum revolution per minute. Okay. Actually, do you know it is it is a long formula? If you have watched the lectures, then please tell me. Otherwise, you will jump to the solution itself. If you know it is an empirical formula. It is having a lot of exponents also. Okay. If you know it, then please calculate. Otherwise, we will move into the solution part. Okay. Okay. Okay, it's an empirical formula actually. It has been taught in the questions. Okay, it in the lectures. Okay, please try to solve see them. Okay, see here. Everything has been given. This is a screen, this is a agitator, then this is a tank, then this is a drain. Okay. So what is particular in this question? We have been asked that this agitator pedal would be have to be revolved in what RPM or would be the speed so that the mixture would get agitated properly. We have been given a lot of parameters in this particular question. This is a lengthy question. Okay. Volume of tank has been given 1000 liter. It would be equal to 1 meter cube. Diameter of the tank has been given as 1 meters. Depth of the tank is 0.85 meters. Number of pedals has been given as 4. 4 pedals I have made in the right hand side. Width of the pedal 180 millimeters. Length of the pedal 220 millimeters. Then location of the shaft above the bottom of the tank that has been provided as 225 millimeters. Agitation factor is 0.89. Empirically you have to calculate. Okay, there is no straight logic for calculating the minimum RPM which has to be provided to the pedal in order to agitate the mixture. Okay, see this particular thing, this particular minimum peripheral speed that has been derived empirically. Okay, so what is the equation here? Sm is the minimum peripheral speed that has been that is equal to 5.39 into a raised to power 0.422 multiplied by r raised to power minus 0.531 multiplied by fe, that agitation factor that has been given as 0.89 in the question that you have to keep into 0. Raised to the power 0.293. Okay, what is a? A is depth of the liquid above the agitator shaft center line. Okay, shaft center line is this one. If you will just see, this is the center line, this particular line. Okay, what is the level of the liquid that is above the shaft center line? What it would be equal to? Depth of the tank, entire depth I can take, that is 850 already given in the question. Okay, minus 225, that is location of the shaft. Okay, that will directly give you a. And then r, what is r is total combined length of all the pedals divided by length of the tank. Okay, length of the tank that has been given as here I think it has been given 1.27. Okay, for all the pedal length you have to just multiply. 4 pedals are there, 4 into 0.180 divided by 1.27, and you will directly get r as 0.57. Okay, then a also we have calculated 625 It's an empirical formula. Okay, you have to keep the units whichever have been kept here, you have to use the same units. I cannot say in this question that use SI units for all the parameters. Okay, then using SM formula, 5.39 into 6 to 25 raised to the power 0.422 multiplied by 0.57 r raised to power minus 0.531 multiplied by 0.89 raised to power 0.293. Okay, and SM would be equal to 106 meters per minute. Then N would be equal to SM divided by pi d, and d has been given as 1 meter. That is why it would be 106 divided by pi. It will be 34 RPM. Okay, and length, I told you that here you have used 4 into 1.180. 0.180 has been mentioned, width of the pedal, but length of the tank has not been given here. Sorry for the confusion. That would be equal to V from the volume itself. You will able to calculate V equal to pi d square by 4 into L. Volume is A into L. Area into length. Area is pi d square by 4 or pi r square of a circle multiplied by length. That would directly give you the volume. So from this equation you have to calculate L also. So L will be 1.27. Okay, then this particular L, when you will use in this particular formula, then you will get SM as 106 meters per minute. Okay, and N would be equal to, as you already know, whenever we have to calculate the RPM, we divide it by pi d. Okay, d is 1 in this case, hence RPM, revolutions per minute, would be your 34. Okay, after the class please try to revisit if the question comes in the examination. I am not a very big fan of this particular type of question. This is an empirical question, okay, that has been taught already in the theory part. I am not a big fan, but if it comes in the examination, it would be very important to solve it empirically. Okay. Moving to the next question. It's a very easy question and the only theoretical question which is there in this particular session. In normalized difference vegetation index NDVI, what is the formula? Okay. Four particular formula have been given here. NDVI equal to NIR plus red over NIR minus red. NIR is near infrared. Okay. That is a particular spectrum of the wavelength. Okay. NIR or plus red. Red is the wavelength of red color. Okay. Or 2 into NIR into red over NIR plus red. Or is it NIR minus red over NIR plus red? Or is it the average of two? Okay. NIR is pixel values from near infrared band and red is pixel values from red band. Okay. This particular NDVI index is getting a lot of push nowadays from the various government ministries itself. Okay. Because from the satellite imagery using this NDVI index, you would be able to calculate what is the greenery in a particular area. Okay. Yes. Try to tell me.
C could be the answer. NDVI equal to NIR minus red divided by NIR plus.
Yes, yes, yes. Very good. It is indeed the correct option. NDVI, normalized difference vegetation index, is given by this formula NIR minus red over NIR plus red. Okay. Now let us try to understand. Okay, what is NIR and it's what it conveys. Okay. And the what is NDVI and what it conveys. Sorry. NDVI is widely used in remote sensing. Okay. It's widely used in remote sensing. Okay. Nowadays, in our image processing from either drones or in case of autonomous ground vehicles, this particular indexing has been vividly used. Okay. In use vividly nowadays. The NDVI is a widely used remote sensing index that measures the health and density of the vegetation. Okay. It is calculated using data from either of the satellite or aerial imagery. Okay. You can use the satellite, you can use aerial imagery. Okay. Typically from sensors that capture light in the red and NIR portions. Both the portions must have to be present in an image. In an RGB image, same analysis can be performed, but here, in case of RGB image, whatever you are seeing in present on your screen, that is RGB image: red, green, blue. These are the primary colors. Every image has been constructed from this particular three colors only. Okay, RGB image. Okay, then NIR is near infrared wavelength. Okay, or near infrared region, whatever you want to say, you can see. Okay, you can say this particular image has to be taken from an infrared camera which can see the infrared wavelength. Okay, normal camera which is there in our smartphones, in our DSLRs and various types of webcam, even that is RGB camera, it can only see red, green and blue colors in visible wavelength spectra. Okay, so the whatever you are seeing presently, that is also RGB. Okay, you can snakes have the ability, and even cats, they have the ability to see infrared waves also. Okay, so their world would be entirely different from our world. Okay, so similar to that, there is a camera which is known as infrared camera. It would be able to see infrared wavelength. Okay, so NIR is that number of pixels in an image which is of your green color. Then green minus red over green plus red, that would give you, or NIR minus red over NIR plus red would give you the NDVI index. This is important. Okay, then you will get that index value. Then how you will interpret, if NDVI is approximately equal to 1, okay, it is very good. In that particular area, greenery would be much more denser, healthier vegetation. If NDVI is approximately equal to 0, then that means no particularly green thing is there. Okay, no greenery is there, that is barren or bare soil, urban areas, low vegetation. If NDVI is less than 0, then what is there? Water, clouds, or non-vegetated surfaces are there. Okay, means the reflectance of that particular surface would be very much high. That is why I am getting a negative value. Means the numerator has to be negative. Means red wavelength is much higher. That is in those particular cases only where the reflectance value is higher. Okay, from snow, from water, from clouds. Okay, this is important here. So in an, if an image has been given to you, then you would be able to calculate what is the greenery percentage. That is the meaning here. Okay. Yes. Applications, a lot of applications are there, and nowadays it is uh, getting into news as well as it is getting into thrust. Okay, a lot much higher as compared to the past 15-20 years, because nowadays global warming is increasing. That is why the research is proceeding in this direction, that we have to increase the NDVI index. We have to just reach the level of 1. Okay, for a lot urban areas as well as rural areas. Okay, we have to prevent the deforestation. Okay, and this is the meaning here. Applications of NDVI in agriculture and forestry, in environment modeling as well as in urban planning is there. Okay, precision agriculture, yes, NDVI can be used to monitor the crop health. Higher the NDVI index would be, higher the greenery would be there in a particular area. This means the stress, particularly water stress, as well as the nutrient stress, competition within the plants, that would be much lower. Okay. Higher NDVI values, what does it indicate? It indicates healthier, greener crops. Okay. It it signals that there is the problem is much lesser. Okay. This is the meaning here. Yes. Moving forward. Okay. Another numerical question. This was the only theoretical question. Now in this particular session, all the questions are theoretical or numerical. No theoretical question is there. Yes. Moving forward. A boom type orchard sprayer tank has the tank capacity of 800 liter. It is equipped with hydraulic agitation. In the third question, that was mechanical agitation. This one is hydraulic agitation. When we use compressed air to agitate the liquid mix. That is thing here. The spray nozzle has a pressure of 1.2 megapascal MPa. Then the minimum recirculation rate for agitating a wettable powder mixture having the agitation factor of Fe equal to 0.68. What would be equal to? Okay. In this particular question, you would be using this particular formula QM. Okay. QM is equal to 1380 V into Fe over P raised to power zero point 0.3. Empirical formula. Okay. Now 1380 QM will directly give you the minimum recirculation rate. Okay. 1380 is 1380. No need to deal with it. V, you have to just keep it in meter cube. So 800 liters, how it would be in meter cube? It would be 800 divided by 60. Okay. 800 divided by 1000, not by 60, 1000. That would be zero point 0.8 meter cubes. Fe, empirical coefficient 0.6 you can keep. Then pressure in kilopascals you have to keep. Okay. Then 1.2 megapascal is 1200 kilopascals. So try to keep it in the formula and try to solve. Okay. Yes.
Option B, 89.5 liter per minute.
Yes, yes, yes. Definitely, you are correct. It is 100% correct. 89.5 liters per minute. Okay. This is the approach here. Tank volume V has been given 800 liter, zero point 0.8 meter cube. Directly we will give. Okay. Pressure of the nozzle is 1.2 megapascals. Agitating factor is 0.68. Okay. Then 1380.8 into 0.68 over 1200 into raised to power point 3. You will keep 89.47 something you will get. That is approximately equal to 89.5. Okay. Might be interested to know why we are going for empirical formula in case of our hydraulic agitation as well as mechanical agitation. I'll tell you the reason. Okay. These formula, how they have been derived, that process you have to understand. Okay. In class 11th and 12th, you must have read the equations of motion s equal to u plus half a t square. Okay. Then 2a is equal to v square minus u square, v equal to u plus at. These are the fundamental equations. Similar to that, from these particular equations, a lot of things have come into picture. So using those particular concepts only, they cannot be directly applied in the physical phenomena such as hydraulic or mechanical agitation. Agitation means a solid is there or a semi-solid is there that has to be properly mixed with a liquid. Okay, this particular process has to be modeled, and that from that modeling only we are getting that those particular relations, that hydraulic agitation, the discharge rate in liters per minute, that is dependent on how many parameters. So empirically we have modeled, first of all we have tried to see the relationships. Okay, that it would be dependent on volume, it would be dependent on pressure, or there are some other factors. Then we try to just see or try to calculate that what that relationship it is it linear, is it quadratic, is it exponential, what is the relationship? How you just get it? You have to calculate all the things, okay, empirically. Then using a software such as excel, you can plot the regression plots. Okay, then you would be able to calculate. First you have to uh, calculate q, then how q is varying with p, then how q is varying with v. Okay, then those particular fe and this 1380 that we have intentionally applied. Okay, so that our formula becomes 100% correct. Okay, now the uh, coefficient of regression r square is more than say 0.95. Okay, so these particular modeling that is carried out in lab, and then these formula have come into the picture. Okay, the kinematic analysis that will give you some formula. Okay, the broader thing is dealt in theory of machine course. Okay, that will give you the linkage as well as the links, how the links are moving, what would be the velocity. So similar concept is there in this particular thing only. Okay, so they have been formulated empirically. You have to see how discharge is just varying with the pressure and how is it varying with the volume. Then you would be able to just plot. Okay, and after plotting and carrying out the regression analysis, these formula have come into the picture. That is why the coefficients are not normal, it is zero point 0.3, or the agitation factor is 0.89. So this is experimental, that is why these particular formulas haven't come into the picture. Okay, moving forward, next question for the day. In a nozzle test experiment, hydraulic nozzles are fixed at a height of 500 above the ground. Pressure is maintained at 275 kilopascal. Pressure is decreased by 50%. What would be the percentage change in the flow rate of the nozzle at a spray angle of 60 degree? Assume that the flow rate through the nozzle is proportional to the square root of the pressure. Last line was not in the question. This I intentionally I have to give you. I gave you so that you don't get confused, as well as the question becomes clear to you. Q is directly proportional to root of P. Okay. Initial discharge rate was Q1, so Q1 equal to K times root of P1. Then Q2 is equal to same coefficient K times root of 0.5 P1. So percentage change, just try to calculate what would be the percentage change. That would be equal to Q1 minus Q2 divided by Q1 into 100. Okay. I'll just write it down. No problem. No thing is there. Q1, see here, discharge rate is directly proportional to square root of pressure only. Okay. It is not dependent on height above the ground. It is not dependent on your spray angle. Okay. It is directly proportional to root of pressure. So I have incorporated this coefficient K1 root of P1. Okay. Then Q2 is K2 root of P2. P2 is equal to 0.5 into P1. Okay. Then you have to calculate Q1 minus Q2 over Q1 into 100. That would be the percentage change. Okay. Try to calculate. Everything will get cancelled. Okay. You would be left with some easy equation. Okay. This is K1 only. Okay. At both the places, K1 would be same. So Q1 would be K into root of P1. Q2 would be equal to K1 into root of P1 into 0.5. Then Q1 minus Q2 over Q1 into 100 that you have to calculate. Okay. This is the percentage change. Yes, please do try to calculate. And if this type of question comes in the examination, then please directly solve it. Okay. Don't get confused that I have been given a lot of parameters, height above the ground and spray angle. Okay.
Option B, 29.3%.
Yes, yes, yes. Very good. It is indeed correct. 29.3 percentage. That is the percentage of decrease. Okay. Yes. Q directly proportional to root of P. Okay. Under root of P. Okay. That initially I have told you. Then P2 would be, P1 has been given as 275 kilopascal. P2 would be equal to zero point 0.5 of 275. You need not to calculate anything because everything has been done here. Okay. Initially you will see that everything will get cancelled out. So need not to calculate. Okay. Here I have calculated for clarification. Some of the students might get confused. That is why I have provided the entire clarification. Then percentage decrease, then you can directly calculate either by this method or by this method which I have provided you, Q1 minus Q2 over Q1 into 100 directly. Okay. That would be 29.3 percentage. Okay. Yes. Moving forward, see here another numerical question. Plunger type piston pump of a power sprayer has a stroke length and diameter equal to 12 centimeters and 50 millimeters. Pump is operating at a speed of 220 rpm and it is having two plungers. Then the suction capacity of the pump. Okay. No need to get confused. Okay. Q is A into L. I already told you of a piston type plunger pump. It would be cylindrical in structure like your pichkari. Okay. That thing in which from which we used to play in our holy celebration. Okay. The similar thing is there in your piston pump. Okay. First it will suck the water and then it will discharge it through end nozzle. Okay. The pressure would be increased. Okay. That is the entire functionality of a piston pump. Okay. Plunger type piston pump. So Q is given by the formula A into L. A is your area, that is pi d square by 4. Okay, area is then multiplied by length. Then N and small n. Capital N would be the number of plungers. Okay, small n would be the RPM that will directly give you the discharge rate in liters per minute. Okay, No need to calculate it in liters per minute. Initially, try to calculate it in SI units. Keep everything in SI unit, then you will get the discharge rate in meter cube per second. After that, in whatever unit it is being asked, you can directly put it. Okay. Everything has been given, diameter has been given, then capital N RPM has been given, 220 RPM is there. Okay. Number of plungers has been given, length has been given, everything has been given. Just you have to put. Okay. And get the answer. Try to calculate. Follow the SI unit procedure first. Okay. D in SI unit, then everything in SI unit. Then after that, the discharge rate would be meter cube per second multiplied by 1060 also. You will get it in liters per minute. Okay. Yes.
Option one, A,
Mhm.
103.7 liter per minute.
Yes, yes, yes. Very good. It is indeed the correct option, 103.7 liters per minute. Okay. I also calculated along with you only. I got this entire value. L, D, N, small n, everything has been there put in the formula. Capital N is your RPM, okay, operating speed. Small n is your number of plunger. Directly, if you will put everything in the formula, we'll get pi by 4, then D square, then L, then N, and you will get it as 0.1037 meters cube per minute. Okay. Here I haven't divided by 60. That is why directly I am getting it in meter cube per minute. But standard procedure which we follow is everything in SI unit. Then in whatever unit the question is asking, we try to calculate. Okay. Directly we will get it 103.7 milliliters per minute. Okay. Very good. Moving forward to the next question. Yes. Sprayer having zero point 0.9 liters per minute of nozzle discharge rate and 70 centimeter width of coverage is required to apply 1.1 kg of active ingredient per hectare. 1 kg of ingredient is contained in 100 liters of spray solution. Then what should be the sprayer speed? Okay. Two things are just coming into the picture here. The AFC, actual field capacity, that can be calculated two different ways. Okay. First thing is your spray rate has been given 100 liters of spray solution. That has to be your no, your actual coverage that has been given 1.1 kg of active ingredient per hectare. Okay. So from that you calculate one actual field capacity. Okay. Then another thing has to be calculated from the discharge rate, zero point 0.9 liter per minute of nozzle discharge at a 70 centimeter width of coverage. Then the entire speed you would be able to calculate S into W divided by 10. Okay. Inverse of that will give you time. So time directly you have to equate. Then you would be able to calculate what is the speed. Take your time, please. See the entire question. I have not provided a solution here only. because I want you first to try. Take 5-10 minutes. It's a complicated question. That is why I'm giving you enough time. There are 2-3 approaches. Okay, whichever suits you, try to calculate. If you fail, please. I will after the 5 minutes. I'll tell you the entire solution. But here I am not providing you the hints so that you all also try to apply logic. Okay, try to calculate. Okay, how you will approach this question? The approach only matters. Okay. After, if you will struggle, I'll tell you the entire solution. No problem is there. Okay, take your time. Intentionally, I have not provided the solution at the very first attempt because it's a tricky question and it is important from the examination point of view. I want first you to retry, then I'll tell you. Okay. No problem. See here, the solution I'll provide. Okay, it's a very tricky question. I know it. Okay. See, nozzle sprayer. First thing was nozzle discharge rate. That has been given as 0.9 liters per minute. First question. Okay. First line only. The spacing has been provided as 70 centimeters. See here, 70 centimeters is the width of coverage. Okay. Then 1.1 kg of active ingredient is dissolved in your 1.1 kg of active ingredient per hectare. Okay. 1 kg is dissolved in 100 liter of solution. That was given here. So 1.1 kg of active ingredient in your 100 liters, then the in it would be equivalent to 110 liters. Okay. 100 multiplied by 1.1. Okay. Then the application rate, that would be equal to 110 liters per hectare. Okay. 1.1 kg of active ingredient has to be sprayed in your 1 hectare field, and that has to be mixed with 100 liters of water. So that means the entire volume would be equal to 110, 1.1 multiplied by 100. Okay. Liters per hectare. That would be your application rate. Okay. The another thing was using the formula theoretical field capacity S into W divided by 10. Zero point 0.7 spacing has been given. Then S that we have to calculate divided by 10. Okay, that would be your TFC. Inverse of that would be your time, hours per hectare. So from your second equation, I got this particular thing that time required to cover 1 hectare field would be 10 over zero point 0.7 multiplied by S. Okay, that many hours. For 1 hectare, that would be equal to this number of hours. Then time required to spray 1 hectare field, that can be alternatively 110 liters per hectare. That was my uh, requirement. Okay, 110 liters per hectare, that was my requirement. So that would be equal to 110. Okay, uh, zero point 0.9 was your liters per minute. Okay, zero point 0.9 was your nozzle discharge rate. So dividing it by 110 divided by 110 is your in liters per hectare. Okay, then denominator keeping it in as your liters per minute. Okay, then multiplying it by 60, that would be the unit balance, and directly you will get hours per hectare. Okay, then for 1 hectare, that would be those number of hours. Equating these two equations, okay, you will get speed as 8.2 kilometers. Okay, in the second part it is quite tricky. Okay, you have to use both the things. Yes, 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 please do tell me.
Sir, please make me understand how we generated equation 2.
I'll tell you, no problem, no problem, I'll tell you. See here, 1.1 kg of active ingredient has to be dissolved. Okay, that application rate, first of all we will try to see. That would be equal to 1.1 kg of active ingredient that has to be mixed with 100 liters of water. Entire volume would be 110 liters of hectare. That is the application rate. This is in liters per hectare. Okay, then point 0.9 liters per minute. Okay, then liters per minute, if I remove it, multiply it by 60, that would be liters per hour. Okay, then equation, then if you will see, that would, this entire unit would be hours per hectare. But for 1 hour, okay, for 1 hectare field, not 1 hour, for 1 hectare field, this entire thing would be these many number of hours. These many number of hours are required to spray our field. Okay, for spray our 1 hectare field. Okay, so I have equated hours only. These hours can be directly calculated by this formula only, S into W divided by 10. That will give me the theoretical field capacity. Inverse of that would be hours only, hours per hectare. For 1 hectare, those many numbers of hours are there. So 10 upon 0.7 into S, that would be my first equation. Second thing, yeah, into 60, yeah, very, very good. See here, zero point 0.9 liters per minute has been given. So zero point 0.9 into 60 would be the liters per hour. Okay, unit I have to keep the same. For 1 hour, that would be for 1 hectare, that would be 110 over zero point 0.9 into 60 hours. Okay, so from 1 and 2, I am just equating the number of hours. That is the only thing. Okay, so S, the speed that has to be, that was asked in this particular question, that directly I can calculate from this particular equation, it would be 8.2. Okay, after the examination, please see it once more. After the this particular session, please see it once more, twice more. Okay, you should be in a position to calculate this type of questions. Not every question would be easy. Okay, these are tricky questions. Okay, after the class is over, I'll post the handouts. Please see it once again. Okay, how things are getting into the picture, because some twist is there. That is why I told you first try to read it, then I'll tell you the question, then I will tell you the solution. T1 and T2, the time has to be equated from equation 1 and 2, then you will get the speed. Okay, it is inverse calculation. direct calculation. There no formula is there. Formula is there, but I will not tell you, because in that, if something is missing, then how you will be able to calculate? Okay. Common question in gate examinations. After the session is over, please revisit it. If you have any doubt, then please do ask me in the next session. Okay. Then another theoretical question: in electrostatic spraying, the charging of a spray liquid can be achieved by induction charging of the conductive liquid, ionized charging of the conductive or non-conductive liquid, or direct charging of the semi-conductive liquid, or all of these. Okay, this is being asked. What's your opinion on that? Then we will see the electrostatic charging. Yes.
Sir, option D, all of these.
Yes, yes, definitely you are correct. Let us see the electrostatic spring in great detail. Okay. The electrostatic spring, it's charging of the spray liquid. The spray liquid has to be charged, and that can be done through various methods, and all of these are valid methods. In your first method, induction charging of conductive liquid, this method involves using an electric field to induce your charge on the conductive liquid. Okay. First thing is your electric field usage. Another thing is using your ionized charging. Ionized charging means directly ionizing the air or the source, inducing both the things in contact with each other so that the charge is induced in my liquid. Other method is direct charging of semiconductive liquid, means directly applying the charge to the semiconductive liquid. Okay, which has the properties between those of conductor or an insulator. Is it is semiconductor. Okay, all of these are valid methods. I'll tell you the entire procedure, don't worry. Okay, this is how electrostatic sprayers work. Okay, see here, airflow is there and a liquid is there. Both of these will work simultaneously, and the charge has to be induced inside the liquid, so that from the opposite nature, okay, the attraction happens due to the Coulomb's law of attraction. Means two charges, when they are separated through a distance r, they are pulled towards each other, and the Coulombic force which applies on both the charge, positive as well as negative charge, is given by 1 upon 4 pi epsilon naught q1 q2 divided by r. Okay, f is given by this formula that you must have read in your class 11th. F equal to 1 upon 4 pi epsilon naught q1 q2 divided by r. Epsilon naught is a standard coefficient. Okay, you can check the value and you can calculate how much Coulombic force of attraction is there. So from that concept only, we are trying to induce the charge. Okay, so here the charge we are trying to induce from the airflow. The airflow, if it is positively charged, then my liquid, which is at neutral stage, that will directly induce or absorb some of the charged particles that would be there. The charged particles would get mixed with the liquid stream. Okay, then if the entire liquid is positively charged, and if my surface, okay, if it is neutrally charged, then the attraction would not happen. The surface on which the spring has to occur, that has to be also charged. Most of the cases it is negatively charged. Why it is negatively, it is either negatively charged or it is neutrally charged. Okay, so the deposition will always occur on the surface. Okay, this is the concept. Okay, then how to induce the charge, that has been provided. The detailed view you can see in my nozzle, airflow is there as well as liquid flow is there, and charging is getting happened. Okay, then this is a particular reference which I have taken. See here, this is an cross-sectional view or the exploded view of the electrostatic charging unit with an insulated induction electrode for air assisted or charged sprayer. Okay, tractor mounted air assisted or charged sprayer. Here two particular 1 and 2, the in the labeling you can see These are the inlet as well as the outlets of the nozzle. Okay, from the inlet stream you have to induce air. In this particular case, they have induced air. Air is positively charged from inlet 1, that would be introduced. The liquid is entering from the liquid inlet, and at the outlet, which is given as number 2. Okay, at the outlet you will have a charged liquid stream. Okay, this is the thing here. See here, they have used insulated induction electrode. That was one of the option in this particular question. Okay, insulated induction electrode they have used. Would be used for providing the charge to the liquid stream. The design as well as the inter and outer dimensions are given here. How they are charging this particular uh, electrode, they have placed inside the water. Okay, then they are providing 12-volt DC using a battery. Okay, so that particular electrode would be charged. Okay, because the water, it's a neutral medium. Okay, so then electrode, when it is immersed, okay, inside the inside the electrode which you have kept, that if it is immersed inside the water, okay, then dipole moment would be generated, charge segregation would be there, and the entire electrode would be charged positively from this voltage source. Okay, because two different, the grounding or the negative charge you have provided to the water, and you are introducing a high voltage to a to my electrode, then the due to that repulsion forces, the electrode would be entirely positively charged. Okay, this is the concept behind. Then those particular units which were there, first one unit they have showed here how the charging is happening. Then those 3 units they have combined, because the charge has to be multiplied. Okay, from this process, 12 volts only if you are inducing the charge, that would not be sufficient to spray in the entire field. Okay, the charge would not be of such more high value. Okay, so multiplying the charge, we have incorporated 3 different units. Okay, 3 units you can see in at an angle of 60 degree. Symmetrically we have provided 3 different units. Okay, then the entire thing is there from the outlet. All the things I have explained you. Air pressure is inducing at unit number 4, you can see. Okay, then a blower fan is there that will just blow the charged liquid as well as the air along with it. Okay, everything I have explained you. That particular water along with the air has to be channeled so that the outside drop gets sprayed with it. That is why we have provided a huge fan turbulence chamber. Okay, and everything has been there, like voltmeter or multimeter you can provide for checking the value of the unit. Okay, high voltage is being provided here, then induction of the charge, it is there. Okay, electrode is there, and air pressure has been induced here. Okay, this is the complete view of the air assisted sprayer with electrostatic charging units with deposition trials. Okay, they have see here at ninth number. Okay, at ninth number they have just placed some papers. Okay, these are papers for checking the spray pattern as well as what is the volume of spray. Okay, they have genuinely placed those papers. Okay, and this is the complete view. You can see here not many nozzles are there. 3, 4, 5. Okay, two is the at 2 number they have placed the electrodes. Okay, first is your spray tank. Okay, then 3, you can see various number of electrode connections are going. Okay, then 1 is the your air assisted blower. Okay, which will blow the entire air along with the liquid charged mixture. Okay, so this is the theory as well as the application of electrostatic spraying. Okay, moving forward to the last question for the day. This is also a tricky question. A field sprayer having a horizontal boom with 8 nozzles spaced 40 centimeters apart is designed for a maximum application rate of 300 liters per hectare at 800 kPa. The nozzles have a spray angle 60 degree. In this particular question, this is very important. Pattern is such that 40% overlap is there. From this particular informations, you can calculate that what is the height above the top of the plants. The boom should be mounted. The machine is operated at a speed of 6 kilometers per hour. Okay, try to calculate what should be the height. Okay, try to make a figure like this. Okay, these are two nozzles. Okay, they have been placed at what is the distance, 40 centimeters apart. The nozzle angle has been given as 60 degree. Entire angle is 60, means 30 would be there. Okay, and 40% is the overlap, so keep it in mind and try to calculate what should be the height of the spray. Okay, yes, try to draw the figure like this, then I'll tell you how to calculate. Okay, the height above the plants. It's a tricky question. Okay, not a tricky but a detailed question. Analysis is required. Okay, yes, take your time. First of all, try to note down what are the parameters that have been given. Okay, that will give you the initial idea. After that, try to see for yourself. Okay, read what has been given, what has to be calculated. Okay, then we will see. Yes. Now we will see how this question has to be tackled. Okay, if you know the geometry, then very easily you would be able to calculate. See here, two nozzles are there. This figure, try to see. Then the spacing has been provided as 40 centimeters. Okay, 40% is the overlapping. So the overlapping value would be 16 centimeters. Okay, in this particular thing, I'll just tell you. Okay, number of booms have been given 8. No need to see this. Okay, spacing has been given between two nozzles as your 40 centimeters. Okay, here two nozzles are there. I have drawn. Spacing is 40 centimeters. Overlap between the two nozzles is 40%. So 40% of 40 is 16 centimeters. Okay, 16 centimeter is the overlap. Then I have to calculate what is the height that is given by capital H. Okay. Then this d by 2 entire thing, if it is d, then d by 2, you can see d is the entire width of coverage. That is also often asked in the questions. Okay, that is not asked in this question, but can be asked. Then you have to draw this figure. You have to mark both the nozzles. You have to see what is the overlap percentage, and then your question would be very easy. So two triangles are there. Okay, I'll just write it down. Try to focus on uh, this triangle. Triangle A, B, and C. C is this particular point. Okay, this point. And another triangle is there. That is, yes, yes, yes. Please do ask me.
No, the screen was not visible. Now it's visible.
Okay, okay. Then one another triangle is there. Okay, this particular triangle is A, B, and C. Right hand triangle A, B, and C. And inside of that, another triangle is there that is given by X. This particular point is Y. Okay, X, Y, and C. Two similar triangles I can just draw from this geometry. Okay, first of all, I have drawn the two nozzles. Okay, spacing is 40 centimeter, overlap is 40%. So 40% of 40 is 16. Okay, so overlap I have taken 16 centimeter. Then I have made two triangles. First triangle is ABC. Another inside of that, another triangle I can make, that is given by X, Y, and your C. C is this point. Okay, at the bottom end of small h. Okay, so AB I have been provided as capital H, XY I have been provided as small h. Okay, if I take it as a small h, okay, then you try to see here BAC angle, it would be equal to 30 degree, and similarly YXC angle would be equal to 30 degree. Do you agree?
Yes.
Yes. Okay. If you agree, then very easy to solve this question. Small h, we have to calculate. First step is calculation of small h, and inside of triangle XYC, I have been given this particular angle YXC as 30 degree. Okay, and in this angle, if these both the triangles, if I take this point as uh, Z, this point as Z, this one point, then two triangles are there. Okay, one triangle is XYC, another triangle is XYZ. Okay, two overlaps are there like this. I'll make this figure also. Entire confusion I'll remove. X, Y, then C. Okay, then Z. Entire thing I'll see. I'll make. Then ZC distance, that is 16 centimeters. So YC distance would be half of that, 8 centimeters. Okay. So if YC is 8 centimeters, then using the tan theta, okay, 8 divided by small h would be tan 30 degree in triangle XYC. Okay. From the geometry, I have calculated ZC I have been provided. ZC I have seen it as 16 centimeter. So YC would be half of it because both the triangles are symmetrical. Okay. So using tan theta, YC over small h is equal to my tan 30 degree. So YC, if I know it as 8, then small h would be 8 divided by tan 30. That would be equal to 13.86. Directly, small h. If I know my small h, then using similar triangle property, what I will write? I will write capital H in triangles A, B, C and X, Y, C. Capital H. Okay, I'll change the color because it will not be visible. Just a second. Yes. Capital H over small h. That would be equal to, I have been provided one more distance. Okay. That would be equal to, just a second. Yes, I haven't marked one this distance. 40 centimeter is the spacing. So my distance by by would be equal to 20. Okay, by would be equal to 20 in the figure. By has been provided as 20 and yc I know it is 8. Okay, so capital H over small h using the property of similar triangles would be equal to my distance d and c, dc, okay, divided by yc. What is the value of dc? dc is equal to by plus yc. That would be equal to 28. Small h I know, capital H I know, capital H I want to calculate, equal to dc, that is 28, okay, and divided by my small one yc, that is 8. Okay, everything I know, then small h I can directly calculate as 48.5 centimeters. Okay, this would be my approach to this particular question. Okay, might be it is looking complicated, I can understand, but when you will practice, then you will be able to solve. Okay, in this particular question, as an extension to this question, in the examination often it is asked what is the overlap. Okay, this is a very favorite question of the BTech examinations, semester examinations. In this particular question, you would be asked what is the overlap. So if you are asked overlap, then this 16 centimeter I have given you in this question, then you take this 16 centimeter as is x, and keeping it as unknown from the other parameters that has been given to you, maybe you are provided the height, capital H. Okay, from what height the spray is getting. Then if you are asked overlap, then similar approach you can follow. Okay, I'll repeat it once more. Okay, no problem, because it is a important question from the examination point of view as well as for your understanding point of view. Reverse of that, this question in examination overlap is asked, or the second question is height of spring is asked, and both the questions are dealt in similar fashion. Okay, approach I will tell you. In this question, I have been asked what is the height of spring. I have been given as my distance between two nozzles as 50 centimeter. I have been provided spray angle as 60 degree. Half of 60 degree is 30 degree. So I have made the geometry like this. Okay. Then I have said that what is the overlap? Overlap is 40% of the nozzle spacing. That 40% of 40 is 16 centimeters. Then I have made the entire figure. I have made the geometry. Okay. See, two triangles can be made, not two, three triangles can be made. First triangle I have made it ABC, the right hand side triangle. Then another triangle I can make is XYC, another triangle XYZ. Okay, So this distance ZC is been given here as 16 centimeter that I have calculated overlap. Okay. So YC I will be able to calculate because both the triangles are following a similar geometry. Okay. One side is common, the XY is common. Okay. Everything is symmetrical. And from similarity criteria, I can calculate YX C angle also as 30 degree. So YC, if I'll try to calculate, it would be half of 16, that is 8 centimeter. YC is known to me. Angle YXC is known to me. Okay. Then using tan theta value. Okay. Tan theta from the geometry in triangle XYC, I have calculated YC over H equal to tan 30 degree. Okay. So from here, H I have calculated as 8 upon tan 30 degree. So H value, small h value, I have known as 13.86 centimeters. Okay. Moving to the one big triangle and one small triangle. First triangle is ABC, another triangle is XYC. Both the triangles are similar, so from similarity criteria, I can say capital H over small h is given by my DC over YC. Okay. DC, not exactly DC.
It's BC.
Yeah, it's BC, not DC, it's BC. Sorry for mistake. Here I should have corrected it. I'll just calculate BC. It's not DC, it's BC. Sorry for the mistake. Capital H over small h equal to BC over YC from the similarity criteria. Okay. And BC is the sum of two lengths, that is BY plus YC. Okay. So BY value I have calculated is 20. Okay. Half of my 40. 40 half because everything is symmetrical. Okay. BY value I have calculated as 20. Then YC value is 8. BY plus YC I got as 20 plus 8, 28. Okay. Then I have put it in the formula or put it in the equation and I have got the value as small h as 48.5 centimeters. In the examination and as an extension to this, you will not be given this 16 centimeters and you would be asked giving you the h value as 48.5. Okay. Then you would be asked to calculate what is the nozzle overlap. Okay. It's an another favorite question of the semester examinations. Okay. So similarly, I have told you the entire theory. You can calculate. Okay. This is from my side. If you are having any doubt, then please do tell me. I'll explain each and everything, whichever you ask. If you have no doubt, then the session is over from my side. Okay. Thank you for joining the session. Please do join the session next week at the same time. Okay. It would be very helpful for your understanding. Okay. Thank you once again for joining. Okay. Yes.
Sir, I have a question. May I share my screen? Sir, you are not audible.
Yes. I think the call got disconnected. That is why I was not audible. I was just saying that thank you for joining the session. The session is over from my side. Please do join the session next week at the same time. Okay. If you are having any problem, then please do ask me. Otherwise, you can kindly leave. Thank you once again for joining the session. Okay. That is what I wanted to convey. I, uh, I was audible in the question, right?
Yeah, yeah. You were.
Okay, okay,
I have a
okay.
question. May
Yes,
I
yes,
see
yes.
your
Please,
question?
please do ask me. Please do ask me. Yes, yes, yes. A tractor-operated boom sprayer with hollow cone nozzle for fungicide application has application rate. Forward speed has been given. Okay. Nozzle spacing has been given. Okay. Yes. Orifice diameter has been given. Pressure required. Yes. That directly you can calculate. Available 0.787. Yes. Liters per minute. The pressure required. Okay. Yes. Q directly proportional to root over P that I told you in this particular session only. You can see here Q1 they have given you 0.575 liters per minute. Then P1 they must have given you as 275 kilopascals. Now they have changed the conditions. Okay, P2. Let us say it is P2. Okay, the pressure required for desired nozzle. In this particular question, first you have to calculate the discharge rate. Okay, discharge rate you have to calculate. What is the discharge rate in liters per minute? First you have to calculate. Then this is a two-step question. I am telling you the approach. Okay, you just try to follow. Okay, first thing is Q directly proportional to root of P that we will use. Another thing is first you will calculate what is the discharge rate which is required. Okay, then for my discharge rate condition, if Q2 would be known to me, then I'll be able to calculate it as I'll be able to calculate Q1. Okay, or anything you can interchange. First, you have to know the discharge rate. The application rate has been given liters per hectare. Okay. Then available orifice diameter, you don't have to use it. Okay. The forward speed has been given and the nozzle spacing has been given. So I have told you the TFC, the actual field capacity would be S into W divided by T. Okay. So that will come in hectares per hour. So liters per hectare that has been given application rate, multiply both of them liters per hectare into hectares per hour. Okay. What you will get? Liters per hour. Divided by 60, then discharge rate will come in liters per minute. Okay. That for that discharge rate, they are asking what is the pressure. Okay. So Q1 you can take it. Okay. That would be the value which would be coming. Then Q2 is your 0.575. Then P2 is 275. Q1 you already have calculated from above values, the approach which I told you. Then P2 you can directly calculate because Q is directly proportional to root of P. Okay. Is it clear?
Yeah, I got the
Huh.
means you can say understanding of the concept
Uh-huh.
which I will
Uh-huh.
use to solve, but I am not sure
Uh-huh.
that I get the correct answer or not.
Okay, okay. Might be there some the approach I told you might be there some thing is there some thing is missing. Okay, I'll calculate. Don't worry. I'll calculate. I'll tell you the exact answer. No problem. Just give me a second. I'll calculate. No problem. The value which I am getting is 39.054 kilopascals. Are you able to see the screen which I am showing? I've calculated on the
No.
first page only. No? Okay, I'll just share. No problem. See here, I've calculated the entire thing. It is not coming in the options. I don't know why. There might be some error, but I have calculated each and everything. Okay. See here, the actual field capacity which I am getting is 0.325 hectares per hour. Okay. Then multiplying the both the values, I am getting discharge rate as 1.354 liters per minute. Okay. You will also get the same if you follow the same approach. Then 1.354 divided by 0.575 is equal to root of P over root of 275. Okay. If I solve this particular question, then P would be, I think, square of that. Okay. 1525. Yes, now it is matching. First option. Sorry for my thing. P would be 1525. First option in your case. Now it is completely matching. P is 1525 kilopascals. Okay. Shall I explain once more? Or is it clear?
Sir, wait for a moment, sir. I'm just
Okay,
checking.
okay. Yes. You also calculate. No problem. With me, you also try to calculate. Okay. You will get it. 1525 kilopascals.
Yeah, got that.
Got that?
Once again, you can say in short.
Yes. I'll tell you the entire thing. See here. The actual field capacity, I have just first of all used. Okay. Actual field capacity in this question that I'll calculate using S into W divided by 10. Okay. Speed has been given 6.5 kilometers per hour, nozzle spacing 50. So 6.5 multiplied by zero point 0.5 divided by 10. Okay. 6.5 multiplied by zero point 0.5 divided by 10, that is 0.325, 0.325 hectares per hour. Okay.
Yeah.
That is actual field capacity. Then this application rate has been given 250 liters per hectare. 250 liters per hectare multiplied by 0.35 325 hectares per hour. Okay, that will give me the application rate in liters per hour. Okay, try to calculate with me simultaneously. You will get it. So what I am getting, 81.25 liters per hour. That only I have written Q1. 81.525 liters per hour. Dividing it by 60, 1.354 liters per minute. Okay. So using the approach that I told you, 1.354 Q is directly proportional to root of P. So equation I have formulated 1.354. Yes. Want to ask something?
How much in liter per hour?
In liters per hour, 81.25.
You have multiplied it by 60.
No.
Then
250 multiplied by 0.325. Hectares per hour multiplied by liters per hectare. Simple approach.
okay.
Got it? Okay. Then divided it by 60 liters per hour. Got it? 1.354 No, 81.25 liters per hour. Got it?
Got it, got it.
Okay. Then divided by 60, 1.354 liters per minute. Okay. Then using the approach Q1 by Q2 equal to under root of P1 by P2. Okay. 1.354 divided by 0.575 that have been given in the question equal to under root of P divided by under root of 275. Okay. From this equation, if I'll calculate P, I'll get it as 1525 kilopascals. Okay.
Yes.
Okay. Thank you.
Thank you, sir. Have a nice day.
Okay. 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 Thank you so much. Thank you all for joining. Thank you once again.